So I can start, or is there any introduction from Brian? Or
Welcome everyone to our fifth installment of the Mekong Water Data Hour. This is a series of virtual webinars that are supported by the U.S. Department of State, Mekong U.S. Partnership, and we're very excited to take a deep dive into an important topic today. That is how dam development in the Mekong Basin is impacting fish biodiversity and fish biodiversity loss. My name is Brian Eiler. I'm the director of the Stimson Center's Southeast Asia program and also co-lead on the Mekong Dam Monitor. And this study that we're going to look at today, in many ways, like the work of the Mekong Dam Monitor and other new work that's coming out, is kind of a turning point in knowledge and understanding of what's happening in the Mekong Basin. And it's important because the science and the data that is now being collected and disseminated is very powerful, because no longer are we, those who watch the Mekong, relying on assessments of stock. Let's say, how much water is in the river, or the number of fish that are in the river, the number of fish species that are in the river. No longer are we relying on predictions of how impacts will change what is in the river, whether it's the amount of water or the amount of sediment or the amount of fish or the fish biodiversity. But now the actual impacts are being studied and understood. And this is important because once the actual impacts are understood, pathways to change and adaptation and mitigation can be put forward. So this study is one of the first that definitively and through a peer review process shows what the impacts of dams are to fish biodiversity in the lower Mekong. And we have the benefit and the great pleasure of having the two authors on this study with us, Dr. Sorata, who is the director of the graduate school at the National University of Chiesem Kamchemyer. He received his double PhD degree from Ghent University in Belgium and the University of Paul Sabatier, Toulouse, in 2017. And he conducts research in an array of disciplines: ecology, dam trade-offs, biodiversity, and many other aspects. His co-author with us today is Dr. Sarah Null, who is Associate Professor at of Watershed Sciences Department at Utah State University. Dr. Sarah Null is calling in from Utah. Thank you for calling in at this early hour. She uses her background in water resources, systems, and analysis, and physical geography to monitor and mathematically model processes and interactions of built and natural water resources system. She's been working on the Mekong for some years now. And importantly, I want to note that the funding and the support for this study came from USAID Wonders of the Mekong, which by my opinion is producing much of the cutting edge research coming out of the Mekong that is advancing our understanding of what's happening in the Mekong system. So today, during our Mekong Water Data Hour, as always, we're going to take a deep dive into the study. We're going to look at the data. We're going to talk about some of the methods that were used, and importantly, focus on the findings and implications. That will happen over the first 20-25 minutes of our experience together. And then after that, we've invited two discussants to engage our speakers. Our old friend Sinsamut Umbuntazane, who's the Mekong Director and Fisheries Biologist at Fish Bio in Vientiane, Laos, and Dr. Binh Dang Thuy, who's a Senior Lecturer and Researcher. She'll be joining us with Sinsamut at the end of the presentation to give a discussion, and I'll give a bit more of an introduction to Sinsamut and Thuy then. But for now, let's turn it over to our speakers, Rata and Sarah. Thank you for joining us, and we look forward to learning more about your study.
Okay, thank you very much, Brian. And good evening from Cambodia here. It's a bit evening, and good morning for the US. So today it is my pleasure to present you some recent research finding from the Mekong, and the title is "Fish Biodiversity Declines with Dam Development in the Lower Mekong Basin," and with my co-author here, Cheryl from Utah State University. And before getting to the point, I would like to let you know something about fish and the livelihood for the people in the Lower Mekong Basin. For most of the people in this basin or in the region, they depend highly on fish as their protein intake. And in total, the intakes around 1.1 to 0.10 to zero point 0.8 kilogram per day for each of the people in this area. And collectively, from a very previous estimation, the total fish catch was about 1.3 to 2.7 million tons that are harvested from the lower Mekong Basin. So in short, we call LMB, so the lower Mekong Basin. These figures value around 11 billion US dollars back to 2015, which is about, let's say, like 13 billion US dollar in 2022. So it is a huge amount of like value that we get from the fish. Most of the fish that harvested are small cyprinids, and as you can see in the figures, they dominate the catch. And in Khmer, we say trailil, or we can say money fish. So these money fish contribute like a lot to the catch and also to the economic of the people. And the people, they earn the money or they get their food from the fish and other fisheries. So in each catch, we can also find other fish species, and mostly they are migratory fish that most of the people catch by net or by other fishing gears. These diversity of fish mainly are driven by the hydrology of the Mekong, and which is drained from the upper part of the Mekong, like from Moon River or Chi Moon River, from Thailand, and also from a region shared by Laos, Vietnam, and Cambodia called the 3S. So the 3S is, as you can see here, so the upper left, it is the Southeast Asian mainland region, and the red dot here on the screen is the 3S. So the 3S rivers, they comprises three rivers that starts with S. So Sekong, Sesan, and Srapo. This system is crucially important for fish migrations and also for the hydrology for supporting the like annual rainfall and the annual hydrology of the Mekong as well, in particular in the Tonle Sap Lake and the Mekong Delta. However, the 3S is very popular, or we can say it is booming with dam development. As you can see on the map, a lot of dam already exist, and are some are planned, some are proposed, and some are under constructions. Okay, so the 3S here, Sesan is the most dam rivers, in particular on the main stem, and then Srapok, and the least dam one is Sekong. And the red triangle here is the recently built dam, Lower Sesan 2 Dam. So this dam is huge and block many, so like thousands of kilometers of fish migration and the habitat for fish. For the second here, it is one of the free flowing rivers that occur in the whole 3S, I mean the whole lower Mekong basin. And there are also dams that propose in this basin. And one of the proposed one is called Sekong Lower Sekong Dam, as you can see in the mouse here. So if there is no dam happening now, no Sekong Dam here, the free-flowing habitats, the free-flowing rivers can provide around 10,300 kilometers that can be accessible to migratory fish. However, if this second dam is built, it will block around 4,700 kilometers habitats next to the upstream dam. However, the recent, like last year or early this year, there is an ongoing round on the Sekong main stem dam sharing between Cambodia and Laos, somewhere here, like but there's no symbol on the map. But it is now happening. We call Lower Sekong Dam A, which is already commissioned and under construction already. So with that said, the Sekong Dam, I mean, the Sekong River is also lost another maybe half of the habitats from the previous finding by Nul 2021. So this is about the 3S system and the dam in the 3S. Because of the dam developments and the importance for fish and also hydrology, we want to know how the fish are changed because of the dam. Talking of fish, in particular, the migratory fish, among the 3S, striped support the highest migratory species, in total 81, and followed by the Sekong, and the least one is Seisan. Okay, so this is the important for the migratory fish. And collectively, all the 3S, they support 89. And you can see 89 in total, but Strapbook support already 81. So it's really a lot. And Sekong is 64. In terms of hydrology, the 3S support between 25 to 28% of the Mekong mean annual flow. So this is a huge amount of hydrology. So for our research that is just published, we would like to assess the effects of hydropower dam development on the spatial temporal changes in fish biodiversity based on the data from 2007 to 2014. So this is one of the longest time series data that we have. So the data we use to analyze the spatial temporal change of fish biodiversity and also to assess the impact of dam. We divided the data into two parts. Okay, so the first part, it is about community data that we want to quantify the spatial seasonal variation. With the fish community data, we first transform to Hellinger form because the Hellinger transform data, it can minimize the impacts of the most abundant species and also the least occurring species. With this transform Hellinger data, we use the principal component analysis to illustrate how the fish in the 3S distinct from one to another. So this is the assessment of spatial seasonal variations. And the second, we use the fish data based on species count, based on richness, based on abundance and diversity to regress against times and number of dams. As a result, for this spatial seasonal variation based on the principal component analysis, we found that the 3S support distinct fish communities, as you can see in the ordination maps on the left, A. So they are separated by the ordination map, meaning that they support distinct fish communities. While on the right-hand side, we can see some of the the data, in particular, SK means Sekong. So Sekong, dried and wet, they are more or less overlap, meaning that fish community between two seasons, dried and wet, are quite similar, which is different from Striped SP, wet and dried, and Seisan SS, wet and dry. They are different during the dried and wet seasons. For the species count, we found that Sekong in that time it support the highest of species, the divided to the total fish, divided to migratory and threatens. So these three fish matrix Sekong support the highest number of species, followed by Stradbroke SP, and the least species count we found was the Seisan. And in terms of richness, we also found mostly the second support higher number of species, followed by the Strapog, the green one. And the least one is Cesar with the red. For the species abundance, they are more or less the same with the species abundance, but they're different in terms of the species richness as indicated above. And because of that, it lead to the difference in species diversity index as well. We found most of the fish matrix, total fish, migratory fish, and threatened fish. Sekong has a higher fish diversity indices. So this is in terms of special variations. For temporal variations, we found that in Sekong, on the left column, over time, we found more fish and fish, while in Sharpok, we found less and less, and also in Sesan. Over time, we found less and less fish. So this is the main result that we found. After finding the temporal decline of the fish, we want to know what are the factors, and then we would like to know about the numbers of dams that built each year and how the fish, annual fish species, richness, abundance, and diversity change over each year as well. This the number of dams that we quantify. So the red one is Sesan, and the blue is Shrapok, and the green is Sekong. So Sekong is the least one. Sesan is the most dam. Collectively, it is 51 dam in the 3S. And when we regress the number of dam here with the annual fish abundance, fish richness, fish diversity index, we found in Sekong, okay, in Sekong River, the number of fish individual, whether they are total fish or they are migratory fish or they are threatened fish, they increase over the studied years, 8 year of the study period. While in Shatbok and Seisan, most of the metrics decline. And similarly, with the fish richness, over the studied year, the richness increased significantly in Sekong, while it decreased significantly in Shatbok and Sesan as well. So this is the general figures that we found from our study. Regarding diversity index, it is more or less the same with the other two matrices with diversity, richness, and abundance. So the Shannon diversity index, they increase in Sekong over time, while in Stradbroke and Sesan, we found at least one of the matrix decline. Based on our results, we try to find some implication for the conservation and the development of the 3S. Based on our study, we demonstrate that hydropower dam in the 3S has caused on fisheries, biodiversity loss, degraded ecosystem, for instance, because of the regulated hydrology, it leads to the degraded water quality and change in hydrology in the downstream parts. and dam has blocked migratory fish route, and also they disturb the fish spawning ground and also the spawning ground, although they are considered as renewable and sustainable source of energies. So because of the impact, it is imperative that for the further dam plant or the under construction, it may be need a realistic environmental impact assessment, because this kind of realistic environmental impact assessment can provide us a better insight that we can have in order to aid like policy makers or the development planning. So here is the lower second that I mentioned. So now it is not damned yet. And the new minister of the agriculture and fishery forestry, he declared that no dam in his era. So it is a good news for Cambodia as well. Although the dam sharing between Cambodia and Laos is also already in constructions. So based on our result, it indicate that the connectivity in the Sekong and as well as connected to the Cambodian Mekong and the Tonle Sap, it is a very good river or corridor that we need to do the conservation, because it can also include the sustainable environment and social costs. The free-flowing Sekong connect to the Mekong and the Tonle Sap can support diverse freshwater resources and also the wild capture fisheries. Okay, and this is what we think it is a really good corridor for most of the fish migrations. Okay, other than conservation or the preserving this corridor, maybe other renewable resources like solar energy or reoperating existing dam or cascade dam to maximize hydropower generation is better better than building a new dam. So this is what becomes for the implication based on our finding. So you can also find our published article in online. It is already published a month ago. So here it is. You can click on the link, or you can just search. Yeah, so I think that's all for my presentation, and maybe 2 or 3 minutes over. So thank you very much for attending and attention. Thank you.
Thank you, Rata. Thanks for going over those results. They're certainly not the results we want to hear, but at least there's some suggestion that fish are adapting to their new situation as more dams are built on the Sesan and Srepak. It looks to me like they're choosing a different migratory pathway. I want to ask Dr. Saranol, is this conclusion correct? And what comments do you have to provide and share with us on your very impressive study?
Hi, thank you. Yeah, these results, what you just said is exactly correct. So all of our metrics of biodiversity are declining in the most dammed rivers, so the Saison and the Shraipak. And I was really surprised by our results that in the Sekong, where there's fewer dams, that all of our metrics of biodiversity weren't flat, but were actually increasing. So just like you just said, that's showing that fish are finding other migratory pathways. And that was surprising to me. And I want to just emphasize that we understand from modeling studies or sometimes theoretical studies that this is what should occur, that we should have increasing biodiversity in our free flowing places. But it was really interesting to me that we could see this in an 8-year data set, and so that was a pretty exciting result to me. And Rata did a wonderful job of discussing the implications that maintaining free flowing rivers are really important. Again, so in conceptual modeling studies, we show time and time again that we don't get a lot of benefit from damming every single river. If we want to maintain some of our environmental benefits, it's much better to keep at least one or some rivers free flowing and then reoperate other dams. And this is almost a textbook example where we're seeing that play out in the data. And so dam construction has started on the Mekong, but it's slow moving. It's my understanding that environmental impact statement is being requested. And so hopefully we can slow this process and use science to guide this process somewhat.
Thank you, Sarah, for those comments. Before we go to our discussions, I have a few just a few questions I want to pose to Rata and Sarah. One, importantly, your data set ends in 2014. Um, can you talk to us about why it ends in 2014 and what's happened after 2014 and what some of the impacts could be? We're getting in speculation, but what's happened after 2014 and what some of the impacts could be.
Yeah, I'll start on that and then I'll turn it over to Rata. So the data, I'll let Rata talk about the data set that we used, but since that data set, since 2014, we've had a number of really large dams be constructed and put into operation. Like Lower Saison 2 comes to mind, that effectively blocks the Saison and the Shepak rivers. And so those rivers are disconnected from a kind of 3S, from the 3S, the Cambodian Mekong, and into the Tonle Sap, where we have a really important fish pathway or fish corridor. And Rata, I'll let you talk about the data set and how it was collected and why it stopped in 2014.
Okay, yeah, thank you. That is crucial. So seeing like a speculation of how dam disrupt the fish migration, the Mekong River Commission they started a biomonitoring in the 3S and other parts of the lower Mekong Basin from 2014. And the data we analyzed was from 2007 to, oh, maybe I made a mistake. It started in 2007, okay? And we analyzed from 2007 to 14 because the data was already validated by uh, fish catch specialist already, Dr. Ngao Pengun, one of the co-authors as well. And after 2014, the data is also in the what is it? In the database, but was not clean or was not validated. But recently, Dr. Boon, I, and our team is also exploring how the fish community is changed. In particular, want to see the change after the Lower Sesantu Dam being operated. And the fish collection, we based on the fishers that worked for the Amasi previously, based on a daily basis, and works also for the fishery administration of the Ministry of Fishery and Forestry. The specialists, the fish catch specialists, they train each side three fishers, so they train them and they test. They do the pilot monitorings, and the fish specialists went to the site and do some testing. And after testing and get the reliability of the capacity of the fishes, so they start recording the data from 2004 until now. Yeah.
And just as a follow-up, when do you expect to present a new round of results of, let's say, a newer data set from maybe 2014 to a more recent year?
Seeing another colleague is leading, so I don't know when, but we hope to to release this kind of study soon, and the result is already in our hand. So I think we are hoping to see the result soon. Yeah.
Excellent, very good. Rata, is it
Yeah.
possible that you could press the stop screen sharing button on your computer there so we can see you? It'd be great to see you.
Yeah. Okay. Let me. see. Okay, so
Also like to share a screen, and as long as this works, yes. And just update everyone on the status of the Sekong A Dam. This is the Sekong
yeah,
A Dam, as it's called, or the Sekong downstream dam. We're looking at a picture, an optical image from Planet Labs from June 22nd, just a few days ago, 2023. And you know that the clock is ticking on connectivity on the Sekong. If we look at the location of this dam, here's the Mekong mainstream coming down the left of the map. Sekong River is flowing down to Stung Treng down below. This is the border with Cambodia. The dam is in Laos. It's right on the border with Cambodia, and it's well under construction. You can see much of the foundation of the main dam being built, various spillways going in. I would assess that this is about 70% complete. And now that we're in the wet season, there is a natural pause to construction. Just to give you a feel for how much construction has been done over the last year, this is a June 13th image from 2022, about a year ago. It has progressed. I would assess it would have progressed a little faster over the course of a year, which suggests that some of construction could be delayed. And interestingly, that could be due to the MRC's recent announcement of a transboundary environmental impact assessment that will be done on the Sekong A Dam. Now, this dam does have a fish ladder in its design. It's been discussed through independent third party analysis that the fish ladder is incredibly inadequate, and perhaps the transboundary environmental impact assessment will, I would say at least, improve that fish ladder. But Rata and Sarah, you and I both know, and many others that are familiar with fisheries in the Mekong Basin, know that. Let me see if I can stop sharing. This is a superhighway for various kinds and species of fish moving up through the Sekong, different weights, again, different lengths, and no fish ladder is adequate in a tropical river like this to move the kind of fish through from downstream to upstream and then from upstream to downstream to allow even a fraction of viability of that fish biodiversity to survive. So it's of great concern to us. It's good to see the MRC putting forward a transboundary environmental impact assessment. It's the first of its kind. You know, these should have been done a long time ago. It's being done on a tributary dam, but is it too little, too late? Let's go to our discussants now. We're going to hear from our old friend, Dr. Sinsamut there in Vientiane, a fisheries expert for fish bio, as well as, and I need to give her a proper introduction. She just joined us over the night, so we don't have her bio fully into the system yet, but we're going to hear from Dr. Din Thuy Dang, who's a senior lecturer and researcher and leader of the Biodiversity and Conservation Group at the Institute for Biotechnology and Environment at Nha Trang University in Vietnam. She's an expert on marine fisheries as well as freshwater fisheries, and her research interests include evolution, marine ecology, aquatic biodiversity, and the conservation of aquatic organisms. So, Dr. Thuy, or perhaps Dr. Thuy, what are some of your reactions to this study? And thank you for joining us.
Yeah. Hello, everybody. Thanks for the nice introduction, and also I'm really happy to hear your talk. Unfortunately, the data is only stopped at 2014, so I believe that many things happened after that. So I remember in 2016, I joined one of the meeting in Vientiane. At that time, I know that we know that Lao government they have the plan to build about 7 dam in the Secom River. And at that time we have the meeting, and I also saw for the people in the meeting about our research in the population genetics in the fish in the Mekong, and also the fish in the Free Ed region. And at that time, we are also talking about the Secom is now only the free route for the fish. They can be migrate and also finding the shelter during the dry season. But actually, after this meeting, we have do the very long report and asking about that we should make the Second River free for the fish, because at that time we know that the sesame and the ceropods are on already closed. A lot of them and need connection, and know them in the sesame and the ceropod they have the fish passage. So, but at that time, since 2016 until now, we still know that some dams still develop in the second river. So the situation is more and more serious. So I'm actually surprised about your study. And if you compare the Secom and the Sesan and the Serapop, because we have conduct a lot of sampling in three different river, and especially the Sesan in Highland, Vietnam. So every time we come to the Highland, Vietnam, we see that reduce the number of fish in the market, and we do fishing in the Sesan, but we keep the tilapia, the red tilapia. So some super, but very little fish in the Sesan River in Highland, Vietnam. So I would like to share you some of our research about the population genetics. So we try about 20 different species in the Mekong River. Some of that is endemic for the Free Ed River. So we collect the fish from different population. We do the DNA extraction, and we do the advanced genomic, and we analyze the population genetics, and we have the scientific evidence that the dam have been separate the fish population. And we even have the very sad story about the I'm sure that you know that kind of fish, the Hermibagrus Spilopterus. Do you know that kind of fish? That this is a very common fish in the Sesan and Serapok River, and we found the population in the Đắk Lắk province in the Highland, Vietnam. They are very, very, very low, the effective population size, even only 1.6 or something like that. So I think you are familiar with the effective population size. For the normal species, for the normal population, it should be 1,000 or at least some hundred. But you see, the population in Đắk Lắk is 0.6. So you can say the totally different. So if you got the only 0.6 expected population size, so it means that the population is in danger for the future development for the population. So is now is in danger condition, and Serapop is will be, but Secom is much better. But if we don't do anything for Secom, I think the situation will be like Serapop on Sesan. So we are expect that we may see more decline for the fish maybe after 2014 or up to now. So we try to do a lot of different fish with different life history, Some of the short migration, some a long migration, some in no migration. But we see a lot of disconnectivity of the fish population. So, so I think it in our many aspects. It can be the biology, physiology, population genetics, or your research. So we can see the how the dam impact for the fish population. So I fully agree with you that we need to do something in order to get at least some river or some branching free for the fish. Otherwise, on of the dam will block the migration of the fish. So I also have some of the comment because when you compare the biodiversity index for the Mekong, Sesan, and Serpong, so uh, you the migrate fish, the threatened fish, and what else? The migratory fish, the threatened
Total, yeah.
fish, and I cannot remember
Total
now.
fish.
But
And all fish, all
okay,
species, threatened species and migratory species.
okay. But you see in Sekong, every increase. So it means the threatened fish also increase, but it's opposite direction for the Sesan and Serpong. So I would like you to explain me more about your data as well. Okay, thank you.
Thank you, Dr. Tweedy. Before we go to comments and remarks from Sinsamut, I just want to remind everyone you're tuning in and you have questions. There's been a pop-up coming up at the bottom, it might come up again, of how to pose questions to our speakers. You can go to stimson.org/questions, stimson.org/questions to pose questions to the speakers. And Courtney Weatherby will be facilitating our Q&A session here very soon. But now up to Sensamu. Sensamu, from your perch there in Vientiane upstream, what are your thoughts and comments on this paper?
Thank you for inviting me to join this presentation. This is my first time to join the Stimson Center online presentations, and I appreciate that I have some questions to ask Mr. Rota on behalf of the fisheries biologists. Sorry that my internet connection is not so good because now I'm in Thailand, so I try to express my concern for this report. So it is very good that you have a very strong foundation of fisheries data analysis from 2007 to 2014, which is very good, which is the data that you get from MRC, and also most of the data is from fish catch monitoring or fish catch logbook. Yeah, but my concern is you have to consider in the broad perspective, especially what is the main channel of the fish migration. So normally the fish migrate from the during the rainy season. They migrate from the Tonle Sap and up to the main Mekong river, and some might not go to the Sekong, Sesan, Seprok, and most of the migratory fish and the big fish, they go to the Confor. So now the Confor have a hydropower, like Don Sahong, for example. Even they have a clear fish passage channel that allow the fish go up and go down. So it's still the main barrier for number of fish that can go past to the upstream. That's why some fish some fish community they all also turn their way to the Sekong or Sesan, for example, because of the river, the flow of the river had changed, right? And the volume of the water and the noise, the sound of the water that trick them to migrate to the upstream. So Sekong is most attraction. That's why the number of fish go up to the Sekong compared to Seplot or Sesan, which is lower Sesan, is already dammed. So the questions might similar to the Brian that he asked, uh, what happened after that 2014 until recent, something like that. So this is a very good study that we can learn from up-to-date data, and we can propose to either new development plan for hydropower, especially the Lower Sekong A, and maybe continue with B because I know they plan to build B also, number B, in the future. So that's why Lao or Lao people or Cambodian people, they are also interested to know this analysis in the future also and more update data. So in my opinion, I think that uh, because I've been in Sekong River 2 weeks ago, it seemed that the river is very murky water, very turbid. So it look like very they use security for turbidity about 20 centimeter. It means that water is very turbid right now. It means what happened in the upstream, something like that. The question, yeah. This is my concern, and I think that free water is also important if the hydropower developer they see important, and they also have alternative uh, option, the option for the new uh, hydropower development, maybe wind power, something like that, more less impact to aquatic environment. Yes. Yeah. Thank you.
Thank you, Sensimu. Rata and Sarah, and Sensimu, if you can, could you mute your microphone? We're getting a lot of background noise. Thank you, Sensimu. Just a quick 2-minute reaction to Sensimu and Twee's remarks, and then we'll go to our Q&A. Any thoughts?
Do you want to start, Rata? Then I'll follow up.
Yeah, for the first question to Dr. Tree, I think the answer is more or less like to Brian. Sarah has already stated that the fish, like after having experienced that the migratory route is blocked in the Stratford and Sesan, so they turn their migratory migration to a more flow free. More free flowing rivers to the Sekong. And for the very good and looking to see the new result from 2014 to until the present, yeah, it is also like what I myself and our team really want to see and want to show everyone, the researchers, also scientists, that something is going on in the region. Yeah, so that is what we thought. And like Dr. Tree mentioned, most of the fish catch by local people or in the market, we have already seen the drop in the catch, local catch, and also in the selling. But it is just by observation. There's no empirical like a peer review process like we have. Actually, our data is straightforward. It's just do some analysis to validate something and just show it is one of the empirical to show that the more dam, the fish decline and the fish turn their migration to the more free flowing rivers. So that is a very good point. So that's all for me. So maybe Sarah can add some more. Yeah.
Let's go to the Q&A because Courtney has been pinging me on Slack saying, hey, I've got a lot of great questions coming from our audience. So one final comment from me, and again, thank you everyone for joining before I send this over to Courtney, is that I think the power of what you've done is you've demonstrated a methodology that can be used in other river basins and can encourage other scientists like Sinsamut there in Laos to apply it. And I know Sinsamut is looped into the Wonders of the Mekong team as well, so what better way to demonstrate and to transfer a method. And then finally, Dr. Thuy there in Vietnam, if you all aren't working with Vietnamese fisheries researchers, it seems like Dr. Thuy is a very sensible and a good partner for this type of work. So I hope that our meeting here can result in new partnerships. Courtney, over to you. Thanks, everyone.
Sure, and thank you everyone for submitting your questions. I suspect we're not going to be able to get to all of them, so I'm going to try and prioritize the questions that are most directly linked to this study, although we have some very good questions that I'll try to end on that are talking about some broader, bigger picture aspects of the river system. So I think one question, which I think will be fairly straightforward, but is important to highlight is actually a pretty basic question about river connectivity and how you define free-flowing rivers. So we had a question from one audience member asking if you could a little bit about how you calculated what free-flowing rivers were. So they were noting in your study that 10,331 kilometers were accessible to migratory fish. Obviously, that's much longer than the length of the Mekong River. So can you talk a little bit about how you came to those numbers and how you define free-flowing rivers for your study?
I'm happy to take that one. So we calculated the main stem and then the tributaries that were accessible to migrating fish. And that doesn't necessarily, free flowing doesn't necessarily mean there were absolutely no changes, but there are not barriers impeding, like physical barriers impeding passage. And sometimes when we study connectivity really in depth, we'll find other barriers that aren't so obvious, like thermal barriers or sediment barriers or things like that. But we are looking for physical barriers, and we were including then tributaries that are accessible, given no big dams in the system.
Thanks for that, Sarah. I know that one's fairly straightforward, but it's one of those questions. If someone's not familiar with the terms, it's helpful to define them up front. We have another question, which was actually directed towards Dr. Thuy or the presenter about whether there's been longer term monitoring of the impacts of some of the dams in the upper highlands, like the Aloy or Alin dams, on fish biodiversity, specifically in sort of the upper Mekong. And then the impacts of Upper Sesan and Sripak cascades on those individual rivers. So for instance, thinking of fish migration, obviously you talk about sort of losing connectivity, but do we see changes in sort of the type of fish being available in these upstream portions of the river that might remain connected between dams or other changes in sort of the reservoir areas? So maybe Dr. Thuy, if you want to chime in first from any of your studies in Central Highlands, and then Ratha and Sarah might chime in also.
And just specifically, that's for the Mekong, so the dams high up in the upper Mekong. Dr. Thuy, has any work been done on the dams in the upper Mekong, like the Aloy Dam or other dams far upstream?
I'm sorry, I don't quite understand your question.
Sure, I think the question sort of had a couple parts, but one of them was just a question on has there been good data and studies on how fisheries are changing and developing inside the reservoirs or upstream of the reservoirs in the Central Highlands. So, for instance, looking at the Aloy Dam or the Alin Dam, do you see good data coming out of what's going on locally with fisheries in those areas after they've been disconnected from the downstream?
Um, I'm sorry, I'm not quite sure that I can understand answer your question well, but we actually doing the research not only for the Highland and Vietnam, but we also collect the sample in Mekong, in Sesan and Serapok. In Mekong, we collect the sample uh, Sekom and Atapu. We also collect the sample in Sesan, in Serapok, and also in the Tumcheng, where the mixing with the free air in the Mekong mainstem, and we also collect the sample or large region in the mainstem. So we would like to see that how what is the impact, the main impact for the fish population in the region, and how is the fish with the different behavior can adapt to different environment. So the question the result we got in not only the population in the highland that I share you the question the story about the Dak Lak population in Highland Vietnam, but we also have the same problem with the population from the Sekom and the Atapu. So we can see the highly disconnectivity for the fish in the different region of the river, and also due to the connectivity. So we see some of the scientific evidence for the decline for the population based on based on their genetic information. So I think that if the dam is the continue develop in the region, so we will see more decline and more the lower genetic variation in the fish population. So yeah, our data may be not only in this situation and not this in the time we are studying, because we conduct the research before all of the dam have been set up in the region. So if we see that all of the not all of the dam but many of the dam have been set up in the region, and after that we collect the fish again and we do the same research. So we can see the more trend of the lower genetic variation, and also the disconnectivity of the fish, and the decline of the number of the fish as well. Okay, so I hope that I can get your question.
Thank you, Dr. T. I think that's helpful. And actually, that's a good segue. Unless Sarah or Ratha wants to jump in with an additional comment, I actually think that last comment you made there is a good segue into a couple of other questions from the chat about the use of genetic data and eDNA in particular. So this one's mostly
Yes.
for Ratha and Sarah, but if anyone else wants to chime in, they can. So the first question was, did the study use or refer to any environmental DNA, which has been useful in, for instance, similar studies in the Carnelli-based Hall or elsewhere. And then similarly, and I think building on sort of that slide, Ratha, that you showed with distinct population fish in each of the three S rivers, do you know if population genetics studies show a very distinct subcluster pattern between the populations once dam construction has been completed? So I think there's sort of how much is genetic information playing into the study, and then do you see the opportunity for that to help distinguish between upper and downstream basins once a dam stops connectivity for migration?
Yes.
So I guess maybe
Can I have a question? The last question from me.
sure, if you want to chime in, Sinsamut, that's fine.
Yes. What is a keystone species that you are focusing on fish migratory species? that you would like to suggest in the future? The question to Rota from your study. Thank you.
Thank you, Sinsumet. For the in terms of the species aspect, so the different species like keystone flagships or umbrella species. But for here, I think one of the most like important one that we need to assess and do further investigation is the Sirius microlepis. Is one of the most important as well, and a lot of catch in the in sting tank. And in terms of individual fish here, it is hard to get a population study. So for future, I think it is also a good species that we can investigate. So the Syrinus microlepis.
Microlipid. Uh, can you repeat the name, the Latin name of the fish?
The Syrinus microlepis.
Serious
Yeah, this
microlipid.
is a
Okay.
common species. Yeah, common species.
Yeah.
Mostly they migrate up during June and July, and down in the August and September. Yes. Yeah.
Yes,
For
we
eDNA,
got a lot of
some
fish as well.
analysis can uh, it can interpret only genus level, so it still have a weak point of eDNA, especially uh, the streamfish species and some like endemic species. Yeah, this is the weak point of eDNA when we are trying to conduct the eDNA study. Yeah, this is my point.
Thank you for that, Sintamut. I realize that we're just about at the end of time, so I do want to note we have a lot of questions that have come in just at the end, which we won't have time to answer. I will try to share those with all of our speakers today in case anyone wants to follow up so that we can get some answers out there. But I will ask one sort of final bigger picture question that I think is a useful one to get the drive of what's in the basin. There are obviously two dams which have historically been proposed on the mainstream of the Mekong at Sambor and Stung Treng in Cambodia, which would be between the 3S basin and the Tonle Sap that we talked about. So I think, it's a speculative question for sure, but can we sort of talk a little bit about, what you might expect from that? And then also a question about, the commitment. Have we seen any discussion recently on what the status projects are? The Cambodian government has, officials from the Cambodian government have historically noted that these dams would not move forward until 2030 or that they're off the books. Do we have any updates on that and what impacts that might have on the 3S basin?
Yeah, so the delay statement from the Prime Minister is still there. So no more update or no more talk about the Sambo Dam. So his voice is so strong. And for the Lower Sekong Dam, it was previously proposed by the Royal Company Group and combined with the company from Vietnam and Laos. But the new Minister of Agriculture, Fishery and Forestry, he also make an announcement that there's no dam in his period, in particular the Lower Sekong as well. So that is a good news for the Cambodian side as well, and also a good way forward that fish and biodiversity along the river system can be preserved or better conserved for the development, at least for the next decade. Yeah, maybe Sarah can add something else.
Well said, Rata. I don't have much to add except for the moratorium on Cambodian main stem dams is still in effect. It's not ironclad. Moratoriums with can go away just as soon as they come, and so it would be nice to see very formal protection. But in the meantime, we're happy for that moratorium.
Thank you both for that comment and for those insights and updates. I know we're a little past the hour, so at this point, I do want to thank everyone for their time. I know it's been a great discussion, and hopefully everyone has learned as much as I have about some of the data on fish biodiversity in the 3S Basin and the broader region. So with that, I'm simply going to note we're going to close out for today's event. Thank you to all of our speakers for joining. This is a regular series for our monthly or almost about monthly Mekong Data Hour, Water Data Hour series. So please do plan to join us in late July for our next event. We're probably going to hold off on just doing 1 hour and have a slightly longer event for our seasonal update on where is the water. So watch out for that date announcement. August will probably resume our formal water data hour discussions. So we look forward to seeing many of you return for that. Thank you again for your time, and please do feel free to follow up with further questions via email. We're happy to share those with the panelists.
Yeah.